we've been looking at center of mass just in one direction, but what if you have a bunch of objects, a bunch of point masses arrayed around the xy plane? Maybe the xy plane is a tabletop. You need to measure you need to measure your moments and center of mass in two directions, not just one direction. Because the center of mass is going to be one single point, and if you support this whole setup just at that point, then everything will balance. The nice thing is, right, we know how to measure moments and center of mass along one direction. The nice thing is, in the other direction, it works exactly the same way. So if you want to measure the mass, we looked at the measure of the moment about the y-axis, and it's just the sum of your masses times your positions. The moment about the x-axis looks exactly the same. It's just instead of your horizontal positions, it's your vertical positions, so y sub I. And then the center of mass is, right, before we saw the x-coordinate of the center of mass, the moment about the y-axis divided by the mass. The y-coordinate of the center of mass is the same, but in the other direction, so the moment about the x-axis divided by the center of mass. Do be careful about how the x's and y's all turn out here. So the moment about the x-axis has the y-coordinates in it. The moment about the y-axis has the x-coordinates in it. So that seems backwards, but that's how it is. And then for your centers of mass, the x-coordinate of the center of mass has the moment about the y-axis, and the y-coordinate of the center of mass has the moments about the x-axis. So that also seems backwards, but again, that's the way it works out. So with that in mind, let's find the center of mass of two masses, a 2 kilogram mass at 2, 5, and a 3 kilogram mass at -1, 2. So we can kind of eyeball where the center of mass ought to come out to be. So let's see, 2, 5, that's going to be 1, 2, 3, 4, 5. That's here. So there's 2 kilograms right here. And then -1, 2 here. There's 3 kilograms there. The center of mass, just intuitively, the center of mass ought to be somewhere directly in between these two, but it should be a little closer to the 3 kilogram mass because 3 kilograms is more than 2 kilograms. So it seems like it ought to be maybe somewhere around this red spot. So now that we have some intuitive idea of what it should be, let's do the calculation to see if our intuition was right. So we need the total mass. So 2 kilograms plus 3 kilograms is 5 kilograms. We need the moment about the y-axis, which is, so 2 kilograms times our x-coordinate, which is 2, plus for our 3 kilogram mass, it's 3 kilograms times our x-coordinate, which is -1. So that's going to be 4 minus 3, that's +1. The moment about the x-axis, that's the 2 kilogram mass times the y-coordinate for that mass, which is 5, plus the 3 kilogram mass times the y-coordinate for that mass, which is 2. So 10 plus 6, 16. And so for our center of mass, x bar, y bar, it's the moment about the y-axis, which is 1, divided by the mass, which is 5, and then the moment about the x-axis, which is 16, divided by the mass, which is 5. So 1/5, or 0.2, and then 16/5, that's going to be 3 1/5. And if we look at where that is on the coordinate plane here, in the x direction, it's just to the right of 0. And in the y direction, it's just over 3. So this, I didn't mark up my axis very well, so you can see that this looks like it's about right. So the center of mass in two directions is basically the same as the center of mass in one direction. You just have to do it twice. Once for the x direction, where you use the moment about the y-axis, and once for the y direction, where you use the moment about the x-axis.